Let's talk about the concept of the ratio test. So there are three cases and I would like to discuss the concepts in my own word for each case. So the idea is we have a series, right? So look at the red line. We have A1 plus A2 plus A3 plus A4 all the way to the 1,000 term, 2,000 term, and then we keep on moving. So the idea is we take a current term and the next term, and then we set up a ratio. So the way we set it up is we take the next term divided by the current term, and then there are three cases. The ratio is either less than 1, greater than 1, or equal to 1. So to avoid having the plus and the minuses, the alternating series, we would like to take the absolute value of the ratio. All right, so the first case is the series is convergent or absolute convergence. So the way we set up the ratio is we take the absolute value of an plus 1 divided by the an. So using my own word, the an plus 1, I would like to call it the next term, and then the an, I would like to call it the current term. So to simplify this language one step further, that means in order for a fraction to be less than 1, we must have a small value on top divided by a big value on the bottom. So let's say we have 7 divided by 8, that is less than 1, right? A small divided by big, the quotient is less than 1. So using this language, we say that the next value are getting smaller. The next value is less than the current value. If you keep on moving, the sum of this series is only determined by the first couple terms. So let's say you look at the red line again, right? From A1 all the way to 1,000 or A2,000. So the an and the an plus 1. So for the red line, just imagine, just picture this in your mind. You look at the red line, 1, 2, 3, 4, 5, A6, A7, and then A1000, A2000. If you look all the way to the right hand side of the red line, the red summation, we have a small value divided by the current value, right? So that means those values, as you look all the way to the right, those values are so small, right? So the sum, the series, is only determined by the first couple terms, maybe from A1 all the way to A20. Because as you look all the way to the right of the red line, the red sum, those terms on the right, on all the way on the right, they are so small, so they really don't affect the sum too much. So in this case, the sum is equals to a real number, and therefore the series is convergent. And then case 2 is divergent. So case 2, we do the same thing. We take the next value divided by the current value. So in order for this fraction to be greater than 1, the next value must be greater than the previous value. So let's say a divided by 7. So that means as you move to the right, the next value is greater than the previous value. So if you look at the red line again, the red sum, the number all the way on the right, they are pretty big. So as a result, when you add them up, the sum is equals to infinity, which means the series is divergent. And then case 3 is no conclusion. So case 3, we take the next value divided by the current value. In order for this fraction to be equal to 1, the next value must be equal to the current value. So let's say 5 equals to 5. You have a number divided by itself, you always get a 1. But how come the answer is no conclusion? Because when we set up this ratio, we already use an absolute value to take away all the negatives. So that means you are either adding up a bunch of identical numbers. So I have 3 examples for you. Either you are adding up a bunch of 2, or you will have a 2 minus 2 plus 2 minus 2, or you have some plus first and then with a bunch of minus, and then with a bunch of plus. We don't know which one we are having right now. So that means the sum, we cannot decide that. As a result, the series, convergence or divergence, we don't know. All right. So let me give you 3 lines to generalize each case. So we have that right here. So case 1 is we take the limit as n approaches to 0, the next term divided by the current term. If the result is less than 1, then the series is convergent, because you are adding up a bunch of numbers, right? So A1 plus A2 plus A3 plus A4, and then you go all the way to the right. The numbers right here, the an and the an plus 1, these numbers, they are getting smaller and smaller. They are getting smaller and smaller. That means the sum is really determined by the first couple terms. As a result, the series is convergent. And then case 2 is divergent. You have the next term divided by the current term. The limit is greater than 1. That means the next term is greater than the previous term. So that is the opposite. So if you look all the way to the right of the series, you are adding big numbers. Because the next term is greater than the previous term, you might be having a series like this. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, and then you go all the way. So the next term is always greater than the previous term. As a result, the sum is going to be equal to infinity. As a result, the series is divergent. If you look at the previous case, you get numbers like that, maybe 100 plus 99 plus 98 plus 97 plus 96. If you keep on going, the last couple numbers, they are pretty small. That means the sum is really determined by the first couple numbers. As a result, the sum is equals to a real number, and therefore the series is convergent. And then the last one is no conclusion. So you set up this ratio, and then the limit equals to 1. That means we are not able to determine whether the series is convergent or divergent. So that is the basic concept of the ratio test. In the next video, I will give you many examples for you to apply the ratio test. So if you think my instruction is helpful, please let me know in the comment section below. Like the video, subscribe to my channel, share the video for me. I am sure many other people are looking for similar instruction, especially if you want to say the test using your own word instead of a bunch of symbols. All right, so I see you all in the next lesson. Signing out. See you there.